All right, we're going to talk about surface areas and volumes of spheres. First, I'm going to give you the volume of the sphere, and then I'm going to label some different pieces. I'm not going to derive the volume nor the surface area of the spheres in this video. It's quite the process. However, you could derive the surface area of a sphere. You can get that by working with regular polygons and increasing the number of sides. Volume, you can deal with pyramids and using the formula for surface area of the sphere to find the volume of the sphere. In this video, I'm just going to give the formulas, talk about a few different vocabulary pieces, and then show how to apply the formula, give and find different measures of the sphere based upon a given item. Okay, so what is the formula for surface area of sphere? Well, surface area is equal to 4 pi r squared. Okay, and one thing that is important to note here when we're dealing with surface area here is first some different terms. A great circle. A great circle is a circle that cuts a sphere into two congruent pieces. Okay, and those two congruent pieces, when you cut a sphere in half, they're called hemispheres. Okay, a great circle is the largest circle that you can make around the outside of a circle. All right. If you think of like a globe, a great circle would be the equator. Okay, the other lines of latitude don't work out there. So here's a great circle. All right, and a hemisphere. Hemispheres are the two bottom portions of, or excuse me, the bottom portion and then the top portion of the sphere. Those are hemispheres. Okay, and so if you were to take a circle, just kind of think of it like a dome shape. Okay, that would be a hemisphere here. You know what? Let's kind of dash that up a bit there. Okay, so half of a circle there is a hemisphere. This being your base. Okay. For those of you who live around here in Seattle area, that'd be like the Tacoma Dome, that kind of shape, be your hemisphere. It's not the best looking hemisphere, but there we got it. Okay, so those are hemispheres. Diameter of a sphere, it goes, well, it's probably not the best color to use there. It would go from one side of a great circle all the way to the other. Okay, that is your diameter. Okay, and then your radius would be half of your diameter. So if you were to go from the center out to the outer edge, that is a radius. Okay, so let's go ahead and apply our formula here. All right, so our formula for surface area, remember, is surface area is equal to 4 pi r squared. And so really what you need to know is r. So in this first circle here, or this first sphere, we have a radius of 7. Okay, and so applying our formula, S equals 4 times 49. Okay, 7 squared, 49. And 4 times 49 is 196. 196 pi. And then let's go ahead and round that to nearest tenth. 615.8 square centimeters. Okay. Now we have our answer in terms of pi. We also have our answer rounded to the nearest tenth. Here's our exact answer. Okay. Here's a rounded value. Always try to get it in terms of pi if you can first. Okay. Let's go ahead and try another one here. Find the surface area of this sphere. Well, here they give us the circumference. And remember, in order to find the surface area, we need to know the radius. Well, I do know the circumference. Circumference is equal to, circumference of any circle is equal to 2 pi r. And so if circumference is 8 pi, that would equal 2 pi r. To get r by itself, I'd divide by 2 pi. So to get r is equal to 8 pi divided by 2 pi, which pi's cancel, and 8 divided by 2 is 4. So the radius is 4. Okay, and so we can use that in our surface area formula. S is equal to 4 pi r squared, which is r squared is 16, 4 squared. 4 times 16 is 64, 64 pi, which is approximately 201.1, oops, this one's inches though, square inches. Once again, exact and rounded. Make sure you know what your teacher's looking for, or your textbook. All right, well, let's try to find the diameter given the surface area. Okay, and we know a couple things. First, we know that a diameter is equal to 2 radii. And we know that a surface area is equal to 4 pi r squared. Well, if I can find the radius, I can substitute that in and double it and find the diameter. So let's go ahead and use what we know. We know the circumference, or the surface area, is 34 pi. So I'll substitute that in for s. Okay. And now I'm going to go ahead and divide both sides by 4 pi. Okay, so it's going to give me 34 pi over 4 pi. Well, the pi's are going to cancel. So I get r squared is equal to 34 over 4. Now I know that reduces, however, this is r squared. The next step is to take the square root. So when I take the square root, that's going to be the square root of 34 over the square root of 4. And if I reduce it, I'm going to get 17 halves. Well, 2 is not a perfect square like 4 is. So by not reducing it in this case, I get root 34 over the root of 4, which is 2. That's my radius. If I use that in my formula right here, d equals 2 radiuses. It's root 34 over 2. Well, the 2's cancel, right? That cancels that. So I'm left with the diameter is root 34, which, by the way, is approximately 5.8 centimeters. So once again, exact and rounded. Let's talk about volume. So what's the volume of a sphere? So volume of a sphere, well, volume is equal to 4/3 pi r cubed. And that can be derived, like I said, knowing the volume of a pyramid and knowing the surface area of a sphere. It's just, I'm not going to go through that in this video here. Okay? But once again, the volume depends, just like the surface area does, on the radius. So if I know the radius, 5, it really is just substituting values in. Volume is equal to 4/3 pi times 5 cubed, or 125. Okay, and that is equal to 4 times 125, or 500, over 3 pi. That right there, oops, that is our exact value. There's exact. Now if you're rounding, well, 500 divided by 3 times 3.14 is close to 500. In this case, it's actually 523.6. Okay. Let's try another one. Over here, we know the diameter. So the diameter is 20, which means the radius is 10. So we can use that. D is equal to 4/3 pi r cubed. 10 cubed is 1,000, which is 4,000 over 3 times pi. That is our exact cubic centimeters. Now the rounded is about 4,188.8 cubic centimeters. All right, so find the volume. The surface area of a sphere is 196 pi square inches. What is the volume? Well, if I know surface area is 4 pi r squared. And I need to know volume, which is 4/3 pi r cubed. Once again, these both depend upon R, so you need to know R. Well, I know the surface area, so I'm going to use that and substitute it in. 196 pi. That's equal to 4 pi r squared. I'm going to be able to find r using this. Both sides by 4, right? Okay, so by doing that, 196 pi divided by 4 pi is 49. That's equal to r squared. So I divide it by 4 pi here, divided by 4 pi here. Okay, well, r squared, I take the square root, so r is equal to 7. Well, that's good. If r is 7, I can use that in my formula right there. So my volume now is 4/3 pi times 7 to the third power. Okay, that's 4/3 pi, and 7 to the third is, actually, let's go ahead and multiply. 7 to the third is 49, so 343. Okay, well, 4/3, 343, well, that's 372 over 3 pi. That is my exact value for the volume. It's in cubic inches. My rounded value, I do the math there, is 1,436.8 cubic inches, rounding the nearest tenth. All right. So really just a lot of substituting in and knowing what you're looking for and how to find what you need. One last problem. Find the volume of a composite solid. That means I'm looking at the solid and looking at what it's made up of or not made up of. In this case, it looks like I have a cylinder with a hemisphere taken out, and I want to find the volume. So I need to take the volume of my cylinder and subtract the volume of my hemisphere, or subtract half the volume of my sphere. I want to think of it that way. So that's kind of my plan. The volume of the cylinder is base times height. Okay, well, I'm going to go ahead and complete this side first here. The base, well, this is 16, or excuse me, 4, just like this radius is 4. Okay, so I'm going to say my area of my base is pi r squared times my height, which in this case is 5. And that's going to be 16 pi times 5, which is 80 pi. Okay, so I have 80 pi for volume of the cylinder, and I'm taking away 1/2 volume of the sphere. Volume of the sphere, I look at this sphere, remember the volume of a sphere is equal to 4/3 pi r cubed. And my radius is 4, so I have 1/2 of 4/3 pi times 4 cubed, which is 64. Well, 1/2 of 64 is 32, and 32 times 4 is 128, so I have 128/3 pi, okay, which is, so this times this times this, they multiply to make 128/3. Now, reality is, I kind of get on my class about this today, but make sure you can put these two things together. 80 in terms of thirds, well, that's just 80 times 3. That's 240 pi over 3, right? So if you're trying to get this in thirds, just like that's in thirds, because if you have them in thirds, you've got a common denominator. You just subtract them, right? And this pi can just go up here with the 128. So 240 minus 128 is 132, or excuse me, 112. Okay? And 112 pi over 3, that's my exact answer. It's in cubic inches. My rounded value would be approximately 117.3 cubic inches. All right. That's all I got for you. Good lucky.